Welcome to the cloudonaut podcast. We are your hosts, Andreas and
Michael Wittig. We have been building on AWS since 2009, and in here you can follow along as we develop products like bucketAV, marbot or HyperEnv, and you can learn from basically what we do and we share our experience. This is episode number 80 and we are recording this on September the 15th in 2023. So in case you're watching this live on YouTube or LinkedIn, please send us your questions. We will answer them either like directly or then at the end of the show. So let's get started with what we kind of experienced in the last or in the time between the last show. And one thing that I want to share, which is very kind of fresh because it happened yesterday. So I was visiting the AWS Community Day in Germany. It was located in Munich yesterday. And this was actually my first conference after 3.5 years, and that was kind of caused by the pandemic as well as my son that was born. So it was really a kind of great experience for me to be back talking with other people. And there were around 500 attendees, and it was a great location. There were great talks, and also the people were great. So lots of experience was shared, what people are building on AWS. So I heard incredible cool stories, what people are doing and what problems they run into and what works, what didn't work, and like people migrated to AKS and now they're migrating back to ECS or things like that. So really crazy stuff. And the cool thing about community days is that they are organized by usually by user groups in the country. So for example, in Germany, I think there are around maybe 15 AWS user groups in different cities, and they kind of combine their efforts and some people organize the community day. So it's not organized by AWS, it's kind of an independent event. And this year it was not really related to AWS anymore, so there was no big funding from AWS, so they had lots of sponsors collected. So that was really great. And the big benefit that you get is that first, the event is free, at least in Germany. So I think it depends a little bit on the country, but it's definitely a very cheap compared to AWS events like reInvent, where you pay, I think, $1,800 or something. And the other benefit is that you hear stories from, or you also get a critical opinion, right? I mean, if you go to an AWS event, you will not hear anything bad about AWS. If you go to AWS Community Day, you hear what works and what didn't work. And that is, I think, very helpful because you can avoid a lot of pain if you know what other people already tried out and what was not working. If you if you're lucky and you are based in an area where Community Day is happening, I highly recommend checking them out. So the next events that I just collected from the website is one that happens tomorrow, September 16th, it's in India. So I know it's a big country, so check out the details in which city it is. Then there's one in Italy, October 18th. And then there's one in November in Brazil. So as you can see, it's kind of spread all over the world. There are many other events in between. I just picked some to kind of show you how kind of spread is across the globe. So I shared the link with the dates and the cities where this happens. So check that out, and I can really recommend that. So that was my first topic, Andreas. What do you have to, or what you learned, or what you did in the last? I think it's, I don't know, maybe 1.5 months or something, right? Since our last show.
Yeah, absolutely, quite a long time. Yeah. So during the past weeks, I was mostly working on a new product. And so I can share a little bit into the process of that and the learnings that came along the way. So I was working on GitHub runners for AWS, so basically to deploy self-hosted GitHub runners on AWS and how to do so. And we have been building things like that multiple times, Michael. So we have been building Jenkins infrastructures. We've been building GitHub runners in the past. So we have learned a lot from that, and I've learned a lot from that. So what are the typical options to host such a GitHub runner? So what does the GitHub runner do? It basically executes build jobs from GitHub Actions. And so the most obvious choice is you spin up an EC2 instance, and then you install the GitHub runner, which is just an executable on the machine, and then keep that instance around, log into the machine and configure it and keep it running forever, basically. So that's the simplest approach to that. It comes with some downsides, because the one problem is it doesn't scale. So if you have build jobs piling up and you have a single machine or two machines or what have you, the queue can become quite long, and that means jobs are waiting to get executed, and developers have to wait long times to get feedback from the pipelines. So that's one issue, and the other issue is that jobs, maybe even from different projects, run on the same machine. And this is a security concern because they share the same virtual machine, and it's possible that they, for example, get access to the same memory or even same files on the machine. So it's very hard to sort that out. So the obvious next evolution step is that you solve the scaling issue. And when you do scaling with AWS, auto-scaling is the go-to place. So we have been doing that for Jenkins. We have CloudFormation templates even for that. So which means you just try to increase and or decrease the number of EC2 instances that run your, in this case, GitHub runners. So doing so has a lot of challenges. It's quite complicated to achieve that and do that right, because you have to find a metric that you can scale on. So maybe the number of jobs in the queue or something like that. That is not that easy. And the problem is to scale fast, because you don't want to wait minutes before a new machine starts. And then the other problem is to scale in, so to terminate EC2 instances, because you don't want to interrupt any running jobs. So, Michael, one thing I think you implemented that for Jenkins is to use auto-scaling hooks and then wait until the machine finishes the last job and only then terminate the machine. So that's quite complicated, but in the end, you get a scaling number of machines that provide in GitHub runners, for example. So this is the second evolution. And what I came up during the past weeks and months is a solution that goes one step further. And instead of having EC2 instances provisioned by auto-scaling, which, by the way, also means that you run multiple jobs on the same machine, you might even share the same machines for different projects or different teams. So one idea that I had is why not spin up EC2 machines really on demand in an event-driven way for GitHub runners? And the thing is, so if you read through the GitHub documentation around GitHub runners, it's something that they start even to recommend from a security point of view. And GitHub has even released a new feature, which is called just-in-time runners recently. So with those just-in-time runners, you can now register a GitHub runner, so a machine, only for a single job. So the just-in-time runner spins up, fetches one job, and then terminates itself, or then basically gets deregistered from GitHub. And this is what I've been using. So the architecture looks like this, and I will add a link to a blog post where I've summarized all of that, and also there's an architecture diagram there. But in general, the architecture looks like that. So we have a GitHub webhook that sends events about jobs that are waiting for a runner. The GitHub events come in at an API gateway, which invokes a Lambda function. The Lambda function verifies the message. So there is some way to verify that the message comes from GitHub. You can have a secret that is used to sign the message. So that is all happening in the Lambda function. And then the Lambda function puts the message into an SQS queue. And then a second Lambda function basically consumes messages from the SQS queue. And all it does, more or less, is it registers a just-in-time runner. So it fetches those the token for that from GitHub API, and then launches an EC2 instance by calling the EC2 API. And by the way, that's also the reason for the SQSQ, because the EC2 API has very tight rate limits. So if you want to launch 50 instances with a single API call, you run into issues there. So that is why we have an SQSQ in there to have retries and stuff like that in place. And then the solution works like that. So the EC2 instance launches, and it's configured in a way to launch the GitHub runner, which is just an executable on the machine. It executes a single job, and after that, the machine, so from within the machine, from the operating system, from the script that is running there, the instance gets a shutdown command. And the EC2 instance is configured in a way to then terminate itself in case of a shutdown of the operating system, which means it gets deleted automatically. And so with this approach, there is a single EC2 instance per job, which means from a security perspective, that's great, because there's no way other jobs can interfere with the state on that machine. AWS credentials, what have you, are not accessible from other jobs. And the other thing is it basically offloads the burden of scaling the EC2 infrastructure or the infrastructure for the runner, because we just use on-demand instances. And given the fact that at least in the larger regions, you easily get the M5 or very popular instance types in high quantities, you can just scale by that. And there's no idle resources here, because the instance terminates immediately after the job finishes. So we have no instances that are just waiting for new jobs. Every instance has a job to execute. So that's great. So that's the solution I was working on. And the solution has obviously one downside. The downside is that it takes a little while to spin up a new EC2 instance, right? So it takes, so from my measurements, it takes around a minute for an EC2 instance to launch and then start picking up a job from GitHub. So that is acceptable for many of our GitHub actions, because they run for 30 minutes, even an hour, if you do large integration tests. If you do very short things like, I don't know, linting or code analyzing, stuff like that, it's maybe too long. But we think for many use cases, that's totally acceptable. And you get the advantage that you do not have any idle capacity in your system. And that's great from a cost perspective. Yeah, so that is the solution I was building in the past few months, with weeks and months, with all that knowledge behind. So that is the story with all that. And this resulted in a new release. So last week we released a new product. So now HyperEnv for GitHub Actions is available in the AWS Marketplace. So in case you are in need of self-hosted GitHub runners, check out the solution. You'll find links in the show notes to very simple deploy a solution to your AWS account to host your own GitHub runners. The advantages of doing so why should you consider doing that? So one is to reduce costs. So the GitHub hosted runners, the cloud ones, are quite expensive when you compare it to EC2 costs. So we definitely reduced our GitHub bill by switching to that solution. So we calculate something like 30% more price reduction when doing so. The other reason for running your own runners is that you can configure them to run in your own VPCs. So you can run GitHub runners in a VPC that has connectivity with, I don't know, your database, your internal network over VPN or Direct Connect. So it allows you to do all kinds of those things. And last but not least, so we sell it through the marketplace as an AMI and CloudFormation template bundled together. And what's possible there as well is to modify the AMI slightly to, I don't know, pre-install other libraries or other software packages. So that is the third advantage of running your own GitHub runners.
All right, Andreas. So maybe one kind of side note, this is kind of the second product, right? In a very similar area. So we also had a product. It's not available anymore, so we discontinued it. It was called HyperEnv for Jenkins, and it worked in the same way, right? So for every job, an EC2 instance was started, and then after the job, it was shut it down. And the thing is that it is really more complicated with Jenkins and more, Jenkins is a little bit, the GitHub runner is kind of simple, right? It's a binary, as you said, but the Jenkins is a binary plus or Java plus add-ons or plugins. So it is a little bit more tricky. So we are really looking forward how people are going to use that, and if that is something that other people need, because we actually, we solved that a couple of times for customers. So we think that other people have the same problem. So that's why we created a product, right?
Yeah. And
All right,
Michael, I forgot two things to mention.
Yep.
So one thing is for HyperEnv for Jenkins, basically, we are building an AMI that is a drop-in replacement for the GitHub hosted runners running on Ubuntu 22. So the same things are installed, so you can just replace it, and it works the same way as it did before. And the other thing, so if you listeners of this podcast are interested in giving it a try, so we offer you a free trial for 30 days. So feel free to contact us. You'll find contact details in the show notes, and we're happy to provide you free access for 1 month. So that is about that. So
quick summary from my side, just to make sure that everyone gets how it works. You install HyperEnv for GitHub Actions in your AWS account. Then in your workflow files in GitHub, you change runs on from Ubuntu, for example, 20.04 to HyperEnv. And that's it. Then you get 30% cost reductions. And it is exactly the same thing. It's the same, like all the same tools are installed there compared to the GitHub runner. So it's a 100% clone. It's just a drop-in replacement. Yeah. So it's really straightforward to use it, and it is should work exactly the same way than before, just cheaper and in your own AWS account. All right. So next topic, Andreas, right? I will talk about and what I did with an S3 Object Lambda. And before I kind of introduce the use case, I talk a little bit about what it is actually, like S3 Object Lambdas for everyone who is not familiar with it. The way it works is the first thing to understand it heavily depends on the feature or the capability of S3 called an access point. An access point basically is it's kind of a name for an S3 bucket with its own configuration. Like there's its own policy and things like that. So it's like an S3 bucket, but it's kind of an alias to another bucket, right? But with its own access configuration. So it has a policy, for example, like a bucket policy. So that's kind of important to understand. And Object Lambdas only work with an access point. So it does not work directly with your bucket. So you cannot kind of hook it into your bucket. You have to hook it into an access point kind of. And what then happens is that if someone makes the getObject API call, so to download a file, or make the listObject API call to list all the objects. So those are the two hooks you can use. It invokes a Lambda function with some metadata. Basically, okay, this was the file that was requested. Then you get some information about who kind of requested the file and all kinds of things. And you also get a pre-signed URL to download the file into your Lambda function. Okay, and then you can do whatever you wish with that file with the pre-signed URL. And then there's an API called write getObject response. And you call that API with some tokens that you get in the metadata previously. And you can write whatever you wish there. Like basically you can create a new body for the file. So you could modify the file. This is the examples from AWS. You could transform a file. You can, like, if it's an image, you could add a watermark, whatever you wish, right? You could remove personal PII data, things like that. like on the fly kind of. So that's how it works, right? Okay, so what was my use case that I was trying to implement? So we have this product called bucketAV, which is an antivirus solution for S3. And what I wanted to implement is scan on access. So if someone requests to download a file, I want to quickly scan it, and once it's clean, push it to the user. So sounds easy, right? It also is kind of possible to implement it, and I implemented and I also shipped it already. So it's already a feature of our product. And the interesting thing is that I kind of started looking into this in 2021. Like in May 2021, I wrote a blog post about it. So I can quickly share that link as well. I'll give you 1 second. Okay. So that was the first time when I looked into it. And two things were kind of limiting me in implementing what I wanted to do, like my scanner file before I ship it to the user. And the way S3 Lambda works and the way bucketAV works is a little bit incompatible, because bucketAV has an SQS queue. So you put a message onto an SQS queue, then it scans the file and the result is pushed to an SNS topic. So it's an asynchronous process, right? Object Lambda works a little bit differently. It's like they invoke your Lambda function, and then S3 waits for the Lambda function to terminate. But they also somehow wait for you to call the API. But what you cannot do is you cannot basically stop the Lambda function and then in some other process do something and then call the right get object response API. So that's not possible after the Lambda function is stopped. So that's this was very sad encounter when I realized that, because this would be perfect fit for me. Like in the Object Lambda, I just push the message to SQS, and then once I receive the response, I invoke the right get object response API. But that's not possible. The Lambda function has to continue running. What I also don't want to do is I don't want to transform the file content, right? Because I just want to scan it, and either it is clean, then I just want to the original content should be kind of then made available to the user, or if it's infected, I return a deny, access denied error. Like you can basically have also return error codes. And that's not possible with the right get object response API. If you want to return something, then you have to return it yourself. You cannot just kind of pass the original content to the response API. And that is especially a problem for large files, right? I mean, there are 5 terabyte files possible in S3. If you have a 5 terabyte files in S3, it will not be possible to write this to the get object response API, because there's a kind of tight timeout or kind of deadline to finish that API call. If I remembered correctly, it's actually 30 seconds. So you have 30 seconds to complete the call. So you can never return a large file there. All right, so 2 years later, like remember this was in 2021, like 2 years later, 2023, I looked at the capabilities again. I hoped something changed. Turns out nothing changed actually. So it's still kind of the same thing. So yeah, I was kind of thinking, okay, either I cannot implement this feature or I just kind of work around those limitations. And what I did is I worked around the limitations. So now basically what I do in the Object Lambda, I submit the scan strip to the SQS queue, then I kind of pull a DynamoDB if the result is available, and once the result is available, I call the right get object right response API with the original content of the file and pass that on. I mean, it is not as efficient as it could be from my perspective or for my use case, but it's working for smaller files, I would say. Like I think 20 megabytes is okay, 100 megabytes is also okay, but if you go into the gigabytes, then it's not going to work anymore, which is sad, but for some of our customers, that's perfectly fine. So if you think about images, things like that, or PDF files, I mean, they shouldn't be gigabytes in size. Still, I encountered other issues while implementing it. The Node.js, like we use a lot of Node.js, so a lot of JavaScript, and the new AWS SDK version 3, which you're kind of forced to use if you're running on Lambda Node 18, and if you want to use an inline Lambda because you want to deploy it with CloudFormation easily, things like that. And that was my kind of problem. Then the problem is that the S3 SDK version 3 does not support readable streams as an input to the S3 API. So you basically have to first, I download the file in memory, like then I push it to the get right object response API. So I need memory to hold the whole file, which is again, I mean, it's not efficient. but that's how it is. So I'm kind of limited by the Lambda function memory. So I did test with 10 gigabytes files, and that worked. But we don't recommend for our customers to do that with files that large. So as I said, it's kind of 100 of megabytes is a good use case, but it works with 10 gigabytes actually, if you kind of increase the memory of the Lambda function to its maximum, more or less. The other problem, and this is a very detailed problem, right? But it's something that I encountered, so I will share it. S3 has some additional features to download files where you can specify either the part number or the range of bytes you want to download. This is very convenient if you want to download a large file, and then you can do it in parallel. So you can, for example, request part 1, part 2, part 3, part 4 in parallel, and then kind of utilize your bandwidth, because you cannot fetch one file from S3 with 100 gigs, for example. So they limit what one single download basically can do. So you need to spread across multiple downloads to really get performance out of S3. So this is perfectly working with you request a range of bytes approach, because that is a header. So you can, in the header, basically define what bytes you want to read. For example, you can say, I want to read from byte 0 to byte 10,000, and then you read from byte 10,000 to 20,000, and so on and so forth to get the whole file. So problem with part number is it's a query parameter. And as I told you at the very beginning, is that you get a pre-signed URL from AWS to access the original content. So the pre-signed URL does not know about or does not contain the query parameter, the part number query parameter. So if someone invokes your access point and says, I want to have part number 2, then the pre-signed URL that you get from the S3 service in the metadata is a pre-signed URL for the whole file. So the thing now is that you cannot kind of add the part number to a URL because it is pre-signed. Like it will not work anymore if you do that. And the cool thing with the header, like for the range approaches, that headers are not part of the pre-signed URL. So you can change some headers. I mean, some headers are part of that, but not all of them. So the range header can be added, but not the part number query parameter. So it's impossible to implement that. And I reached out to AWS support, and you will not believe what I received I received the worst support responses ever. Really, it was from a security point. It was really catastrophic what they recommended me doing. And the first responses were just completely wrong. And then they blamed me for not understanding how it works. And then I explained them that it's not possible. And finally, they agreed that it's not possible. But this was really this was one of the worst support experience this year so far. So that was really great. So yeah, I was really kind of shocked by their responses actually. Because if you would just believe what they say, I mean, this would be a security risk if I did what they said. But that said, it is working for our customers, so they can use scan on access. It is heavily limited, unfortunately, and I hope that the Object Lambda gets some love in the future, because for the past 2 years actually there was not much going on there. Because it is actually, I think, a cool feature for some use cases, and I would also love to see this for put object, because we also receive from our customers the request, could you scan our file before it is put into S3? And if you could kind of hook into the put object call or the post object call, that would be great. So I'm looking for some progress there, and see what actually becomes then possible for us and for our customers. That's it, Andreas. So sorry, that was a little bit longer than usual.
That's quite a journey that you got through to make that feature happen. So, Michael, I think there's one topic that we should discuss maybe in the next episode, which is the AWS SDK for JavaScript version 3, because I'm working on migrating many Lambda functions as well, and I've been running into many issues. So one thing that you said is that you said that the version 3 SDK does not support streams for putting objects into S3. But it does so for reading objects. Is that correct, or did I get that wrong as well?
No, it does support it for reading. Okay. I'm not 100% sure. Let me don't say something wrong. Okay. But it was not possible to kind of stream the file from the download to the get object response. write get object response
Okay,
API.
because that's
because
what
it's
I'm
not
currently
yet
working
implemented.
on. So I started yesterday and tried to figure that out. And so I found some things, but I couldn't make it work yet. But yeah, I think that's a good topic for one of the next episodes and a blog post as well,
Yeah.
because many will run into that. Okay, Michael. So anything left or?
I don't think so. I mean, it's already like half an hour past.
So then that's it.
I think we
will
should
be back soon.
Close the show.
Subscribe to our newsletter, the podcast, or the YouTube channel to make sure you're not missing the upcoming episodes. We're looking forward to your feedback. hello@cloudonaut.io or find us on LinkedIn or Mastodon. And as always, you will find all links in the show notes or video description. Thanks a lot for listening.
Bye.
Bye.